Hello everyone, this is the tutorial of y86 sequential processor implementation, and today I'm going to talk about decode and write back stage. Okay, let's get started. Why we talk about decoding and write back stage together? Because they are both using register file. And decoding unit reads data from the register using register ID provided by fetch unit. And write back stage writes data to the register file. And this data is computed during the execution unit, or data came from the memory, data memory, and then write back to the register file. Okay, but here we have this register file is different from the register file you learned in the lecture. What is different? It has 2 ports for read and 2 ports for write. Okay, so if you don't, if you are not familiar with concept of ports, you just consider the input and output of uh, this one circuit one module which does a certain purpose. Okay, in this case, a register file. So here, let's take a look at this figure, and it has 2 input ports, source A and source B, for reading purpose. And these 2 input, we put register ID to these 2 input ports. Then the value of each register will be output through val A, val P, val B. So for read, there are 2 input and output ports. Okay, and also to write data to this register file, there are 2 input ports, and it takes, again, register ID, like where to write. Okay, and then it also takes 2 data input ports coming into register, right, register file. Okay, so this is the different from the in register file you learned. Okay, so we will talk about the how to implement 2 ports register file in the last slide. But here I have a question. So when we want to read, if we want to read the register value using register ID, so why not just use RA and RB value, which is provided by fetch unit? Directly go to the input ports, like to read the register file. Just then we just put RA, RB to the source A and source B. Why not this way? Why it has box on this path? What it does? Okay, so actually this is the extra circuit to generate or to do something, and let's talk about that in the next slide. Okay, here we have one more figure, instruction format. And actually, so we have learned about the value f in the instruction format, and it means in this instruction, in the fetched instruction, the it doesn't have to read register value of RA in this if it is RI move instruction. And also we have another another instruction with F, push and pop. Then we can understand, okay, these two instruction doesn't have to read the register value of RB, okay? But some other instructions like jump instruction and return instruction or halt and no op instruction also doesn't have to read register values, but it does not have f values. Actually, for example, jump instruction cannot put f because we used the byte 1 and byte 2 this position for destination the value. And also no op and halt instruction has only one byte, so we don't use byte 1 for register ID. But again, so those instruction also doesn't have to be don't have to read register files. So then we want to let register file know this case. Okay. So this then in general, okay, for this four gray box, what it does in general, it takes I code and register ID. And if I code say, okay, this instruction does not have to read the register value, then instead of sending the register ID to the register file, it sends the value f. Okay, this is a basic logic of each gray circuit on the figure. Okay, let me take a example. I mean, source B box as an example. Okay, so it takes RB and I code as an input, and it outputs um, register value RB or F depending on I code, and this value goes to the input of input R source B in the register file. Okay, then let's see in which instructions needs to read RB. This this instructions, right? Yeah, sorry. Maybe not this, because this is R move instruction. Source, so we read what's that? RA, we read register RA and then write the RA, the value of RA register to RB. Okay, and then what about RI? Oops, sorry, not again. Okay, and then what about RM? Yes, we need to read RB register because RB has a memory address, base memory address. So we need to read RB register. Okay. What about RM? Not. So RM, yes, because we need to read RB, which is base address. Okay. What else? OPI instruction. Yes, we need to read RB register because RB is both source and destination. So we need to read RB register. And even though we don't implement conditional move, yeah, this conditional move also has to read RB instruction. Okay, then we can write a pseudo code like something like C code. Like, let me write switch case statement. Okay, and then the input is the variable is I code. So if I code is 2, 4, 5, 6, and 2, like 2, 4, 5, 6. Is it 2? Wait a second. Okay, it is 2, but okay, we don't implement this part, so let's not consider this. So if these 4 cases, case 2, case 4, case 5, case 6, then we let's say source value, source would be source B would be what? RB value. We use RB to RB for source B. Otherwise, let's say otherwise, let's say otherwise, the other case, case blah 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 blah. All the other case, we use we assign F to, this is hexa number F to source B. Okay, so you can implement this switch case in this source B part, and definitely you may come up with idea like which component we can use to implement this part. Okay, so you can design circuit for this switch case, and then let me clear this out, and then let's play with one more source A. Okay, so this source A circuit takes RA register ID, and then I code, and then output goes to source A. Okay, same reason. So since it is the input for read, so we need to find the instruction which needs to read source RA register. Okay, so we have RA here, 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 and here. So let's see whether they all need a read register. Okay, so RR move instruction. So we need to read RA register, and then we move that value to the RB. Okay, and also RM. So we need to read RA register. What about RMR move instruction? Okay, actually RA is the destination, right? RA is the destination, so we don't have to read this RA register for this instruction. And also then OPI instruction needs to read RA register, right? RA is the source, and then and so on. Actually, pop needs to RA register for your information, but we don't implement it. Okay, and so on. You can so list out the instructions that needs to read or write, read a register value or write that value to that register. Then you can send the register ID to the register file. Otherwise, we send out, we make a F value and then send to the register file. Okay, this is the how you generate input input to the register file. Okay, so like I said, we have a for input read and write ports here. Okay, let's move on to next slide, and then now let's talk about how to implement two read and write ports here. And I put the figure circuit block diagram of 4x32 register file from the Vahid book. Okay, you can refer figure 4.79 page, which is in page 226. Okay, but this is first, this is 4 by 32 register, but what we need is how many registers like y86 y86 processor has 8, right? So then it is 8 by 32 register. Okay, this is the different thing. So you need to put more 4 more registers here. Okay, and also it has a 2 read and write ports. So in that case, okay, here we have one write address. Okay, and then finally, this data will be stored to the corresponding register based on this address. So if it is if this address indicates register 1, then it will go to the data will be stored in register 1. So this is just, we can just write one data at a time. But if we have 2 ports, which means, let's say we have one more write address as an input, and also we have one more write data coming in. So then maybe you can double, maybe simply speaking, you can double everything and then control them. And then finally you decide to target register to store 2 data. Okay, so here, yeah, we don't have any extra control except decoder here for write. But when you have multiple, yeah, you may have 2 decoders, then you need some extra logic to control data flow. Okay, so I'm giving you a hint. So here you have you need 2 decoder for write, and also you need tri-state buffer to avoid data conflict. Okay, and also the other side, this figure has only one read address and one write address. Okay, and also so we use this tri-state buffer to avoid data conflict, which is going to this same wire. So here, this part, this part, this part, this part. So if we don't have tri-state with control signal, there will be conflict at this point. Okay. So again, so we will have one more address line and data line. Data is actually outgoing. So then first we need one more decoder, and also then we may have more circuit to control those data. Maybe you will need, yeah, another more what's that? Try buffers. Okay. Okay, I think this is good enough, and I hope you will you implement and make it work without any problem. Okay, good. Okay, this is it in this video, and in the next video, I'm going to demonstrate the register decode and write back stage that I implemented. Okay, thank you.